Hello students, welcome to module 17. In this module, we will be discussing the module in 3 units. First unit, we will be discuss about parametric and non-parametric differences, t-test. In the unit 2, we will be discussing about analysis of variance, and unit 3, we will be discussing about chi-square and factor analysis. Unit 1, objective of this unit: to orient the researcher to differentiate between parametric and non-parametric tests, how to draw inference based on the obtained results, how to use t-test, ANOVA, chi-square, inferential statistics. Empirical research has the objective of drawing inferences based on the results obtained of the research. Inferences are drawn based on the data obtained from the sample, which would be extended on to the population. There are 2 types of inferential statistics, namely parametric and non-parametric. Selection of parametric and non-parametric tests depend upon the nature of the variable, type and size of the sample, nature and type of the data. Now let us know the difference between parametric and non-parametric tests. A statistical test in which specific assumptions are made about the population parameter is known as the parametric test. A statistical test used in the case of non-metric independent variables is called non-parametric test. In the parametric test, the test statistics is based on distribution. On the other hand, the test statistic is arbitrary in the case of non-parametric test. In the parametric test, it is assumed that the measurement of variables of interest is done on an interval or a ratio scale, as opposed to the non-parametric test, wherein the variable of interest are measured on a nominal or an ordinal scale. Let us discuss the difference between parametric and non-parametric statistics. In general, the measure of central tendency in the parametric test is mean, while in the case of the non-parametric test, it is the median. Mean is a score. That is where the average score of a particular group is considered for the analysis in a parametric test. Whereas in a non-parametric, the score that is taken is a median. Median is a point and not a score. It cuts the sample into 2 halves, and that is where median becomes an essential factor while analyzing the non-parametric statistics is concerned. In the parametric test, there is complete information about the population. The various characteristic feature of the population is represented in the sample. On the other hand, in the non-parametric test, there is no information about the population, and the researcher is not aware of the various characteristic feature of the population. The applicability of the parametric test is for variables only. For example, if study habits is taken or media habits is taken, it is the variable, the differences in the variable is taken. Whereas the non-parametric test applies both to the variables as well as the attributes. That is where you say, for example, how many of the male and how many of the female there is a difference can be taken. That is where gender is also a variable, and the number of male and the number of female becomes a frequency. In both the cases, actually the non-parametric statistics can be used. The degree of association between the 2 quantitative variables can be measured in terms of correlation using a Pearson coefficient in the case of parametric test. That is where we take the 2 individual independent groups, their scores on the 2 important components are measured in the correlation in the Pearson correlation. Whereas in the case of non-parametric test, that is where Spearman correlation, it is the rank that is being used. Suppose, for example, you say there are 2 newspapers that are being used, and the degree to which these 2 newspapers are liked by a same group is measured, and the rank that is being given to the newspaper is being considered in the non-parametric statistics is concerned. After understanding the difference between parametric and non-parametric statistics, let us move on to one of the popular tests that is being used to compare and to verify the hypothesis of the study. This is known as the t-test. It is also known as the student t-test is concerned. Now, t-test is a popular statistical test used to verify the hypothesis of a research having two groups or two sets of data. Groups could be independent, that is, say for example between the gender male and the female, or urban and the rural, or the different religions. So there are two different independent groups that are there. The differences observed between the two groups, whether it is statistically significant or not, is measured in the case by using the t-test. T-test can also be used when you have a single group, but the group is tested under two different conditions. Suppose for example, before they are exposed to a particular media, and after exposure to the media, is there any difference in their behavior of the single group is measured, and the t-test is used under such circumstances also. T-test can also be used in a third condition, that is where paired t-test, you say the two groups are paired on a single variable, and the difference between the two is being measured using the t-test again. The components of the t-test. In order to measure the t-test or compute the t-test, the two important components are required. One is the means of the two groups is essential, and standard error of mean difference is essential. Standard error of mean difference is measured by using the formula standard deviation and the n size. Now standard deviation is important because standard deviation is a measure that measures the differences between the members of a within a particular group is concerned. Holding other things constant, if the degree of difference is more, that means there are a lot of individual differences within a particular group from the mean is concerned. So the number of individuals, that is where n is important. The standard deviation is an important factor, and standard deviation has two components. Deviation from the mean can be either in a positive direction or in a negative direction. That means an individual may score higher than the mean, or another individual may score lower than the mean. But the error component does not take into consideration the signs, that is plus or minus. That is where standard deviation is squared. So squaring a particular score actually removes the sign, and that is where the degree of standard error of mean difference refers to the actual error that can be attributed to the chance factor and not by the variable that is being manipulated by the researcher is concerned. And how to compute the t-test, the formula for the t-test. The formula for the t-test, as we have already understood the components, the formula for the t-test is mean 1 minus mean 2. The mean 1 and the mean 2 refers to the mean of the group 1 and mean of the group 2 divided by standard error of mean difference. Now as I have already said, standard error of mean difference refers to the degree of deviation that can be attributed only to the chance factor is concerned. Now when you take out the difference between the two means, and from that if you take out the error component, we get what is called as the t ratio. This t ratio is used in order to know whether the observed difference between the two means is statistically significant or not. Now another important component in a t-test is what is called as degrees of freedom. That means holding other things constant, whether the degree of observed difference can be attributed to the real factor that is being observed or due to the chance factor. What is the chance that the other converse of this particular factor can also be abused? Let us come to the interpretation of t-test. The obtained t ratio is checked for the significance level referring to table value. If the obtained t value is greater than the table value, the null hypothesis is rejected. It is interpreted that there is a significant difference between the two groups on the tested variable. Let us take an example of a t-test. The serial addiction level of the male and the female is being tested. Here the male and the female groups become the two independent samples. Now the addiction level of these two groups are measured, and let us assume that the mean of the female is 30 and the mean of the male is 35, and the standard deviation is required. Let us say standard deviation for both the group is 2. Now with these two, we have n of 30, 30 male and 30 female, and mean we have the two mean values and the two SD values we have. With these two, we can compute the t-test. The formula for the t-test, as we have already discussed, mean 1 minus mean 2, the mean of the male and the mean of the female, the difference is obtained. The standard error of mean difference is obtained, that is by you taking the standard deviation of 2 divided by the n of 30 and n of 30 for male and the female, and the root of this will give you standard error of mean difference. The observed difference between the male and the female in terms of the addiction value is measured, and the difference is divided by the standard error of mean difference, the value which we get. And if the difference observed is greater than the t value in the table, then we accept the alternate hypothesis, that is where the male and the female, there is a significant difference in the degree of serial addiction in terms of the addiction level is concerned. Now this is what the t-test, normally this particular t-test is used, this is an example for two independent sample t-test. In the case of a single group that is being measured, as I have discussed earlier, before and after, now there is no two independent sample. The only difference between the mean difference before and the mean difference after is taken into consideration for measuring the standard error of mean difference. And the same formula is being used when you have two paired t-test is also being used. This t-test is a popular test that is being used in the media research whenever the hypothesis test the difference between the two groups are concerned. Thank you.